Yeah, if it was straight up, it would be undefined.
I read that wrong.
Yeah, it would be
just
undefined.
put a hole there.
Yeah. But if it was straight up, you could put a hole there. Sure, absolutely. Yeah. It would be asymptotic behavior. Like it would get infinitely big, maybe. It doesn't have to, but it implies it. Okay, what's another one? Use hands. Let's see another one. So we're supposed to use the definition of derivative. Do you want to use h on this? You guys tend to like h, right?
Yeah.
The limit as h goes to 0. Oh, yeah. Absolutely. F of a plus h minus f of a all over
H.
All over h. Now we're finding the derivative, so instead of a, what are we going to use?
X.
We're going to use x. Exactly. That's the only change we make. We just use x. So what's that going to be? It's going to be the limit as h goes to 0 of x plus h
plus root x plus h minus x minus root
minus, how about this? Minus like this. Or I'm just going to put it in parentheses first. All over what?
H.
So if we simplify this down, looks like we're doing the right thing. What cancels first? What's nice? The x's cancel. That's nice. So what are you left with? You're left with h. Let's keep the limit in there. H plus the square root of x plus h minus all over h. Exactly. So how many people got to this part right here? Or really close to this part? We feeling pretty good that this is where you're supposed to be?
Yeah. And then everything went wrong.
What to do? We can do this. This helps. It doesn't make it super easy, but it helps. You can turn it into h over h times what? Actually, you know what? Let's make it this. H over h plus the square root of x plus h minus the square root of x all over h. The reason we do that is, what does this become? 1. So really, what's the limit as h goes to 0 of 1? 1. You could add limits, right? So this is the same thing as the limit as h goes to 0 of 1 plus the limit as h goes to 0 of x plus h minus the square root of h x over h. You can break that apart, but what is the limit as h goes to 0 of 1?
1.
It is 1. So this is just equal to...
How does that work, though?
How does what work?
If h is approaching 0...
There is no h in there. It's a constant function.
But
No, the answer is not 1. We are nowhere near done.
Didn't you get it from h over h, though?
Yes, h over h.
Approaching 0.
But both of them are approaching at the exact same rate on the top and the bottom. They cancel. H over h is what? 1. So does this help us a little bit? This helps us a little bit. So now we're just looking at this. What do we want to multiply that by? Yeah, some root, right? So we have this over h. What do you want to multiply it by? X plus h plus root x all over x plus h plus root x, like this. Sure. Who knows? I mean, let's do it. There's confidence. Excellent. Okay. So what does the numerator become? It becomes x plus h plus root x times root x plus h minus root x times root x plus h. Oh, is that nice? Bless you. All over. Oh, just x. Thank you. That would have been bad. Times this. Don't need that close parenthesis. We have this right here. Limit as h goes to 0. Exactly. Like that. So what cancels?
The root.
That cancels, right?
That.
And what else cancels? X's. And what are you just left with? H over
H.
Times this.
Oh, right.
Like that. They are messed up. I'm so sorry. So what cancels? That is exactly what we wanted to happen. So we end up with the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. So can we now plug in 0 for h? So this is going to be 1 over root x plus.
Root x.
So it's going to be 1 over
2 root x.
2 root x. And you can leave it like that. So we now know that f prime of x is equal to 1 over 2 root x, which if you really wanted to, you could write it as the square root of x all over 2x, if you really wanted to. I like that better.
I have a question.
What? Oh, 1. There's still the 1. Sorry, sorry.
Yeah.
Plus 1. Ready? 1 plus. So, like that. Sorry. Thank you. Shit. That's very, very important.
And that's the same as 1 plus
Of
F
1 over x plus
H
x
squared.
plus h. I'll just do it out. X plus h squared minus 1 over x squared all over what?
H.
All over h? What are you going to do now?
Distribute.
Yeah, you're going to have to multiply it out, right? So you get 1 over what?
X squared.
Plus 2xh plus minus what? 1 over x squared all over?
H.
Now what do you want to do?
Denominator. So you can.
You want a common denominator?
Yeah.
No? You want a common denominator? I mean, is that okay? Okay. So we end up with x squared minus 2xh plus, no, it's plus, sorry, plus h squared all over, what's our common denominator going to be? X squared times x squared plus 2xh plus all over what? H. I just did a common denominator of the numerator. Are you okay with that? Does something cancel? The x squareds cancel. And you can bring that h right up to there. So what are you left with? You are left with the limit as h goes to 0 of what? 2xh plus all over hx squared times 2xh plus. Oh, thank you. Yep. That would actually collapse the entire thing if I didn't put that in there. 2xh plus. What cancels?
H squared. H.
Well, the h cancels there, and there, right?
Yeah.
That's gone. So you're now left with the limit as h goes to 0 of 2x plus h all over x squared times x squared plus 2xh plus. What else cancels? Oh, so we're not going to cancel yet, but so can we plug in h? Can we plug in 0 for h now? Yeah, we sure can. If we do that, that's 0, and that's 0. So what are you left with? Yeah, did I miss something? Oh, yes, it would be negative. I'm sorry, thank you. I totally forgot that. It should be negative. So this should be negative right there, and that should be negative, right? Thank you very much. So this should be negative. I'll put that in there even though it's irrelevant. But so what do you end up with for an answer? You end up with negative 2x over what? Over what? X to the?
Fourth.
X to the fourth. X squared times x squared. And what does that equal? Yeah, that's absolutely correct. So that would be, you could say negative 2 times x to the negative 3. Yep, there it is. There it is. So f of x is even. What's the derivative? F prime of x is equal to the limit as h goes to 0 of what? F of x plus h minus all over h. Okay? What next? What's the only other thing you can do at this point? Arbitrary, what seems like arbitrary math, and it's really okay if you don't totally buy into this. Labels are almost entirely, how do I say this, irrelevant in a way. Instead of saying negative h, let's just say delta x is going to be negative h. We're just going to say delta x is equal to negative h. If I say that, if I say delta x is equal to negative h, it's just a change from x. It's some distance from x. It's some minuscule piece. What would I end up with? Negative limit of what? Well, not h. What would it be? The limit changes, right? Delta x goes to what?
0.
To 0 of f of x
Plus delta
plus
x.
what? Plus delta x, right? Minus f of x all over
delta x.
delta x right here. What is this right here?
it's the same.
That is what? That is the function for derivative.
Yeah.
That is the function
that's
for
the
derivative.
definition.
That is the definition of derivative right there. That is the definition of derivative. All we've basically proven is we're allowed to come at a derivative from the left or the right. So what does this mean? What's the only thing that's left here? You see that thing up front? What do you end up with? Negative what? F prime of x. This right here is the derivative of f at what? At x. This is the derivative
Yep.
of f at x. So what did we start with? What did we plug in?
Negative x.
So we just showed that f prime of negative x is equal to negative f prime of x. So it's got to be, so f prime of x is what?
Odd. That's odd, isn't it?
That's odd.
Is that odd or even?
That's
That's
odd.
odd.
Thank you. Is odd. Yeah. This is nasty. This is
Ow.
really nasty. Don't worry about it. We're not going to do the second one. I will not ask you this.
Will this something like this be on the test?
No, I just said I will not ask you
Well,
this.
No,
will
no,
it
no,
be on
not
the
your
AP?
test.
On the AP test,
P test.
is stuck between f and h when x is near a, except possibly at a, then the limit as x goes to a of f of x is sorry. There's three things that have to be true. I'm reading this poorly. This has to be true, and this has to be true. So two things. Then this is true. So if if you have your upper bound is h, and your lower bound is f, so here's f of x, here is h of x, then, and you know that near here, so outside of here, maybe it goes outside, right? But then when it gets really close, it gets stuck between. So in this neighborhood around it, g of x is stuck between the two.
So it's L.
So if the upper and the lower go to the same thing, then the middle thing has to go to the same thing. Yeah. So the first thing you have to do is you have to build the bounds.
Mm-hmm.
So you start
That's
with
the
like
most
sine of
difficult
x.
part.
Yeah, that's generally the most difficult part.
Can't
Yep.
you only cross one of the equations because it's less than. Never mind, less
No,
than,
except
equal to-
near a, near a, near a.
Yeah.
Near a. You can do anything you want outside of. That's an arbitrary near a, right?
Mhm.
Near a just means at a certain point it stays between. That's what it means. Questions. Type 5 original test questions. 5 of them. And write out the solutions and the work. Doesn't have to be typed. So you have to type up the questions and then you have to do them out on a separate sheet of paper. Everybody understand the assignment? You can use existing questions for inspiration. If you find a really, really good one that you really, really like, sure, take it, use it, that's fine. But try to find 5 that you think would be great questions that should be doable for a test. The 5 questions shouldn't be what you think the test should be, but 5 questions that could be put into the mix. So you're not designing the 5 questions to take 70 minutes.